In lesson 21, we are looking at special triangles and specifically the 30, 60, 90 triangle. Now, you may remember in our last lesson, we looked at the 45, 45, 90 triangle. And this is a right triangle that is a right isosceles triangle. And that means that both of the sides are the same. And that means that we can understand the specific relationship between the triangle and the angles. Now, in a 45-45 triangle, if both of these sides are x, then the hypotenuse is x the square root of 2. If the legs are the same and they are some unknown value, x, the hypotenuse, the relationship of the hypotenuse to the legs is that the hypotenuse is the square root of 2 times whatever the size of the leg is. So I'll put here 45, 45, 90. Now we want to look at the relationship of the 30, 60, 90. We'll just draw that here. Here we have our right angle. Here we have our 30-degree angle, and here we have our 60-degree angle. Now here, it's very important that you pay just a little bit more attention because in our first triangle, both of the legs were the same, and so there wasn't any need to differentiate them. Here, you have one leg across from the 30-degree angle, and then you have another leg that is across from the 60-degree angle. Now, in this case, if we say that the side across from the 30-degree angle is x, then the side across from the 60-degree angle is x times the square root of 3, and the hypotenuse, which is across from the 90-degree angle, is going to be twice the length of the short side, which in this case is x, and so it's going to be 2x. So this is our general triangle, and now we're going to look at some examples that will show us this relationship. In our first example, we have our first leg is 4, our second leg is 4 the square root of 3, and our hypotenuse is unknown. And we'll just use h for that. Using the Pythagorean theorem, we say that 4 squared plus 4 times the square root of 3 squared is equal to h squared. 4 squared is 16. 4 times the square root of 3, and forgive me, I need to write that correctly. Both the 4 and the square root of 3 should be squared. So 4 squared is 16. The square root of 3 squared is 3, and that's equal to h squared. So we're going to have 16 plus 16 times 3 is 48. 16 plus 48 is 64. The square root of 64 is 8, and the square root of 8 squared is h. And so the length of our hypotenuse is just as we expected. It is twice the length of the short side, which means this is the 30 degrees and this is the 60 degrees. And so we prove that using the Pythagorean theorem. Now we'll do another one. In this example, we've got our 60 up here, our 30 here, and our legs are 7, and 7 the square root of 3. Now, we're already expecting that our hypotenuse will be 14, because that would be twice the length of the short side, but we're going to use the Pythagorean theorem to prove that. Leg squared plus, I did it again, 1 second, plus leg squared is equal to the hypotenuse squared. So that's 49 plus 49 times 3, and that equals h squared. 49 times 3 is 147. 49 plus 147 is 196. And the square root of 196 is 14, which is our value for h, which is exactly what we expected. Now we'll look at another example that uses just letters and the relationship. So again, we have our 60-degree angle here and 30-degree angle, and make sure that you're checking because the 60 won't always be at the top. Your triangles can be any orientation, and so you want to be specifically looking for the side across from the 30-degree angle, and that will be your short side. And then of course the side across from the 60-degree angle, that will be your long side. So if we use S for a short side, and if we use S times the square root of 3 for a long side, and if we say that our hypotenuse is h, then we can have S squared plus S the square root of 3 squared, and that is equal to h squared. So S squared plus S squared times 3 is equal to h squared. So this is S squared plus, it should be 3s squared, is equal to h squared. That means that 4s squared is equal to h squared, and that means that 2s is equal to h. And this is where we got our relationship that the hypotenuse is twice the length of the short side. Now we'll look at another example. And in this case, our short side is 5. Our long side is L, and our hypotenuse is h, and that is equal to 10 actually. So how do we find the long side? Well, 5 squared plus L squared is equal to 10 squared. That means L squared is equal to 100 minus 25. We subtracted 5 squared from both sides. That means L squared is equal to 75. And when we have a number that is not a perfect square, we use a factor that is a perfect square. In this case, that would be 25. And so the square root of 25 times, 1 second, let me write that correctly. This should be L is equal to, there we go, the square root of 25 times the square root of 3. So L is then equal to 5 times the square root of 3. All right. we'll do another. In this example, we've got 60, 30, we're using B, 2B, and L. And that means that B squared plus L squared is equal to 2B squared. That means B squared plus L squared is equal to 4B squared. If we're solving for L squared, then we get L squared is equal to 4B squared minus B squared, which is 3B squared. And that means that L is equal to the square root of 3 times B. We'll just put the B in the front here. This is just basically showing you that the relationship that we proved earlier is the same no matter the right triangle. And so if you have a 30, 60, 90 triangle, the relationship is going to be the same. You're going to have your side across from the 30-degree angle. That's going to be your main side. And then the hypotenuse is going to be twice the length. And the long side is going to be the square root of 3 times that length. So we're going to go to 21A. And we're going to work the problems here. Now it says, if a right triangle has one 30-degree angle, the other angles will have measures of, and of course this is the 30, 60, 90. So that's going to be 60 degrees and 90 degrees. Since a 30, 60, 90 triangle has sides of 3 different lengths, it can be named, we know that sides of 3 different lengths are scalene triangles. If the triangle has all 3 sides the same, that means it is an equilateral triangle. And if it has 2 sides the same, that means it is an isosceles triangle. And then of course, if it has no sides that are the same, which is here in our case of the 30, 60, 90 triangle, that means that it is a scalene triangle. Number 3, the hypotenuse of a 30, 60, 90 triangle is how many times the short leg? It is 2 times the short leg. The long leg of a 30, 60, 90 triangle is how many times the short leg? And that would be the square root of 3 times the short leg. To find the unknown side of any right triangle, we use the Pythagorean theorem. If the hypotenuse of a 30, 60, 90 triangle is known, divide by what to find the short leg, and then do what to that answer by doing what to find the long leg. So this is just kind of a strange way to ask if you know what the hypotenuse is, then what will you do in order to find both the short leg and the long leg. And we looked at that. And so we will place our answers here. If the hypotenuse of a 30, 60, 90 triangle is known, divide by 2 to find the short leg, and then multiply that answer by the square root of 3 to find the long leg. Find the unknown sides of these triangles. So let's look at what we have here. We are given 5. 5 is across from the short leg. A is the long leg. And so that means it's going to be times the square root of 3. And then B is the hypotenuse, which is going to be twice the length of our short leg. And so that's going to be 5 times 2, which is 10. And number 9, we have another triangle. We are given this time the long leg, which is 6 to the square root of 3. So that means the short leg must just be 6. And that's because if the long leg is the short leg times the square root of 3, then the number in front of the radical will be the value. D is our hypotenuse. And if our short leg is 6, then our hypotenuse is going to be 2 times that, which is 12. Now let's go to our back page. And it says, find the unknown sides of these right triangles. And so we're doing the same thing here. For 11, we're looking for the short side. Now, in this case, we have been given our hypotenuse. So we're going to take our hypotenuse and divide by 2. That means that our short side is 5 times the square root of 3. And that means that our long side is the short side times the square root of 3. That's going to be 5 times 3, which is equal to 15. Here we've been given the short side in number 13. That means that our long side is going to be 8 times the square root of 3. And our hypotenuse is going to be 8 times 2, which is 16. Now on number 15, it says ABCD is a rectangle. Side BC is 3, side B, the diagonal there, BD, is 6, and the bottom is 3 to the square root of 3. What are the measures of angle 1 and 2? And I'll draw the triangle here just so we can look at it together. Here is our, let's try again, diagonal. And this is A, B, C, and D. Now, if BC is 3, BD is 6, and DC is 3 to the square root of 3, then hopefully we can see this 3 has to be the short side, which means this angle right here has to be 30 degrees. And this angle right here, which would be 60, would be across from the longer side. So angle 2 is 60, angle 1 is 30. All right, well, that is the end of lesson 31. As always, If you have any questions, send me a message. Otherwise, I'll see you in lesson 20.